All right, so let's begin the slides. The title is Automate Building LRS Network for Transmission Pipelines. My name is Sami Snounu and I work for Critigen. So I'm a certified FME professional. I have 18 years of experience in GIS and specifically in the geospatial data management and system integration. I'm based in Boston, Massachusetts, and I will walk you through this presentation. So for today, I'll describe briefly the solution. It's built based on the information model requirements for the Esri ArcGIS Pipeline Referencing, or the APR tool. The solution is projected towards the gas transmission pipelines, but it could be applied to other utility network domains as well. The main challenge was to create the routes at the beginning. Unfortunately, the APR tool creates one by one route at a time. What about if we have more than 1,000 routes to create? It's going to take time and effort for the team. So how can we automate that? We will see later in this presentation. And what is the LRS network essentially, and what are the key characteristics of a linear reference system network at a high level? So, as nothing is easy at the beginning, in this slide, Zipster is talking to or replying to the FME lizard. Both second me and in that the data is always evolving and getting complex, but FME is such a powerful tool to streamline and help manage any data stream workflow. Well, it didn't take me that much time to decide it's an FME solution, or FME is the one to tackle such task effectively. I can author the translation workspace and repeat the process over and over, and transformer by transformer, until the output comes as proposed and with high quality. In case users updated the data, no problem. Using FME, the whole output can be recreated in just a few minutes. So the solution is for a major private gas utility company in northern east United States, which Critigen helped to implement the first go live in production deployment for the Esri Gas Utility Network. After the implementation of the gas utility network, there was a challenge to the team to build the transmission network of the pipelines for each business area or jurisdiction. So why an automation seems a must here? The answer is that the business asset management group accumulated all the transmission pipes into routes and proposed naming convention, but they didn't know the measure values, or at least how the network would look like at the end. So we came up with Excel master spreadsheet with all the LRS info, mainly the pipeline line ID, the route name, and other route hierarchy information for each jurisdiction. And the aim was to build the network as a whole, to identify issues, fixing them, repeat the process, and so on. Also, it is easier to build and test the result in a file geodatabase. At least at that stage, it was easier to share with the other engineers and examine and QC before the migration to enterprise geodatabase, and then share across the company using webmap services. For the objectives of this presentation, next I will talk about the information model for the Esri APR then the solution proposed using FME, and then what are the key transformers used, following by a quick demo and then a time for your Q&A. All right, so in this slide, the LRS information model to the right of the slide, that's the LRS information model for the Esri APR ArcGIS Pipeline Referencing. It's a many-to-many relationship, and you can see the below the example of the pipeline, how at the end at the ends of the line, it stores the M values. These are the calibration points. The yellow, or looks like the orange dots there at the end of the line, these are the calibration points. It stores the measures. Also, we have the route, or the center line, which is the base of the geometry of the route, that connects to the table, the center line sequence, which record each segment from the center line connected to the route, or the continuous route as we propose in this solution. So the next will be, as the input is a mix of data formats, utility network is stored in a SQL Server database. The routes information in Excel spreadsheet with the help of referencing PDF documentation, an intermediate 5G database at the end. These input to FME workspace that help to build the final output. Further addressing the problem why it's not that basic to build the network. We know so far the LRS is not always up to date or ready to input. Also, the transmission pipeline lack the measures, several geometry and attributes issue identified. The manual process itself is not easy to maintain and keep the network always up to date. The whole process, you need to QC and report and fix the issues found and rebuild the network. So FME is a great tool, and indeed it's like your Swiss knife that tackles any geospatial and non-geospatial data translation and conversion challenges that you can imagine. Another powerful aspect of FME is that you can embed Python code from FME objects and Esri ArcPy libraries within the workspace that can do some extra magic for you. So at a glance, you can see at the top left, the source master spreadsheet along with the Python code used, and you can where you can log the output of the Python code in the log window in the workspace to track the progress. Also, there is a statistics of the resulted network created. Also, the workspace there, inside the workspace, there are several validation stops to ensure the quality of the result and eliminate the reporting like anomalies. It can report anomalies and other geometry or attributes issues found. Also, there's a custom transformer is used to encapsulate a bunch of transformers which served the workspace to become easy to maintain and much readable. Feature reader and feature writer, the transformers can be great to store and retrieve intermediate data while the workspace in the run, and ensure the data stream is connected to the next process. And voila, the FME produce a production-ready data for the business to use and further do advanced editing of the network using the Esri APR tools in the location referencing ribbon. Another slide here shows the result of each of the information model, the center line, the LRS network, and the calibration points and table of the center line sequence. So before I jump to the demo of the workspace, I would like to highlight the key transformers used, and they are listed here. You can refer to the FME transformer booklet, the booklet guide, which SAFE produces for each year, for each FME version. I love to have it handy always next to me. So we have the transformer attribute manager, the FME, the feature merger, the feature joiner, feature reader, feature writer, test filter, attribute keyword, Python caller, length calculator, datetime converter, and the attribute value mapper. And here is the demo. So let me bring the FME workspace. So here you could see the main scripting. There is a startup. Nope, there's not. Okay, I have to cancel. So here is the workspace. At a glance, you could see, looks simple. There is the comments all over. As much as I can, I could add the steps result. Oops. So here is the workspace at a glance, and we could zoom in to see much detailed view here. Aside of the comments all over to make it much readable for the end users, you could see here the first is a pre-processing code for creating a template of the LRS that can hold all the information model. Also, that there is a feature reader that can read from the Excel spreadsheet, and then a feature joiner. Of course, you need to keep all or remove any attributes that can produce maybe anomalies or clutter for your views. And here is the part for creating the route. That's based on feature joiner between the center line and the result coming from the spreadsheet. And that's how you could actually generate the routes. The validate route names, that's, I need to make sure that each segment or the route has a name, or then I would simply abort or report an issue here. That's also, there's also a combined line combiner, for example, sorting, validation. There is feature joiner, another, like you would see a feature joiner coming much handy to connect the data and continue the stream of the data. So the feature merger is sometimes different in behavior than the feature joiner. We could actually describe during the QA and show you that why I needed a feature merger in this, but others I could just use the feature joiner. Python caller to create the calibration points. There's a feature reader. So before reading the feature, there's a writer actually, and here, as you could see, the continuity of the beauty that once you write an output, automatically you can actually ignition or start another process to be as a continuous stream instead of creating like separate workspaces, etc. And also the feature reader that can read the output that just been stored. And then here's a measure loader that's a customer transformer that does the calculations of the measures. There's a bunch of measure transformers in FME that you could utilize. Populating additional attributes. So here is like a length calculator if you want to populate additional attributes, and then you could update the information of the length. Stationing, that's something like advanced. I don't want to talk about it right now. And at the end, you output to a feature writer. So I utilize the parameters a lot here, because that makes it much easier for me to actually utilize the output in the in each transformer. It's much easier to reference as a parameter instead of writing the full path, and it's gonna be tedious to maintain later on. So thank you. That's actually the quick demo. So in conclusion, the key strength of FME is you can get the same output through several design authoring ways, but always think which one will save you the time, the effort to maintain in future if you want to share it with other team members, for example, and also can save your brain. For future work, we will mainly develop another workspace to automate updating the transmission pipeline measures after user LRS edits. We will export the bulk updated user edits to a centralized LRS map service using Esri ArcGIS portal feature service writer. And all right, so I hope you enjoyed learning about the capabilities of FME and how it helped us greatly reducing the time and efforts. By that, I would thank you for your listening. Thank you.